have this technology called Thermoplastic Composites, which, because of the properties of these materials and what you can do with them in manufacturing, offer the opportunity to reduce both weight and cost of products. So ladies and gentlemen, good afternoon. Please welcome to this tutorial. My name is Arnt Offringa, and I will be telling you about thermoplastic composites. I'm an aerospace engineer, and it will be mostly about aerospace developments, aerospace applications. I have a note on automotive. It's not my specialty, it's not our business, but I'd like to show you the parallels between automotive and aerospace. So to start with myself, there's a picture of me in a museum near Dallas with a Fokker triplane, the Red Baron, very famous, First World War. So I work at a company, Aerospace, but Aerospace has bought Fokker as a company, Dutch company, famous for these older aircraft. But we have invested in thermoplastic composites for many, many years. So that's also what we're known for. Long time ago, 1995, I'm in the middle. You see my hair is still not as gray as it is now. This was an important moment, the first primary structure in thermoplastic composites at that moment, which was for the Gulfstream 5 aircraft of Gulfstream in Savannah, here in the US. And there are 15 of these panels which form a structural element, a structural bulkhead above the wing. And it is a thermoplastic sandwich panel. I have a piece of it here. I'll describe it more later. It's a thermoplastic sandwich panel. Thermoplastic skins with a core in between. It's bonded together, but it's primary structure. So it is very heavily loaded. If the failure of this panel can be the failure of the aircraft fuselage. And that was a big step for us, a big honor to develop this for Gulfstream. Today, here's my team, and we have a core team in the Netherlands, a small team of research specialists who develop new technologies. But there's a much larger group of engineers working on thermoplastics. So the Netherlands, that's where I'm based, and there are several suppliers, institutes, universities in thermoplastics also in the Netherlands. It's a small country, and if you're small, you better be good at something. You have some focus. So here's what we're famous for, as you know. Yeah, there we go. But we're also really proud to have developed some very novel technology and products applications. So left top is the horizontal tail of the Augusta Westland 169 light twin helicopter, which is thermoplastic. On the left bottom is a rudder for Gulfstream, several Gulfstream aircraft, which is a welded thermoplastic structure. And on the right is a wing leading edge for Airbus. The facility where I'm located in the Netherlands, in the green, lush countryside. And it's a large composites plant, and that composites plant has been growing and keeps growing. So there is a lot of growth in thermoplastics. There was a nice article in Composites World some years ago about specifically the facility in the Hogeveen location. The Fokker company has a rich history, a heritage, starting 100 years ago. Used to build aircraft, regional aircraft for 50 to 100 passengers. That is all gone, but we are still specialists at aerospace structure. And the organization structure looks like this. At the top is Mr. Hans Butker. He's a Dutch guy, and he likes thermoplastics, which is good for me. And then we have several units. We do have a restructuring going on currently. The North America activities is being combined with European and Asian activities. The Fokker, the Dutch part, is several elements: electrical wiring, services of the flying fleet of aircraft, landing gear, and then on the left top, lightweight aerostructures, and that is basically the area that my team is active in. On the left here, the list of customers. So there's a smaller aircraft like Gulfstream, but also the well-known larger companies such as Boeing and Airbus, Bombardier, etc., using different technologies, different designs. And the company is good at building according to specification, but I guess the way to really add value for a customer is to do design build, to include new technology, to improve the product, then design something and build it. An example is the A380. The A380 has several innovations. So it's the hybrid material, the glare material, new wiring technology, but then also a wing leading edge in full thermoplastic. We do parts for military, such as the F-35 aircraft. This aircraft, the composite part is largely thermoset composites, not so much thermoplastics. And then there's helicopters. For helicopters, the relevance of weight is really, really large. So lightweighting is very important. And that's why this customer, when they saw the products we were doing for Gulfstream, they said, can we try to make it work as well for a helicopter? For example, for the tail of a helicopter, where the weight is really, really critical. And as an example of the importance of weight, the skin on the tail of such a helicopter, if it's aluminum, is 0.3 millimeters. So that's really thin, but it has to be for a helicopter. So the goal of all this technology development is to create technologies that are unique, but also cater to customer needs and create growth. Growth of turnover, growth of profit.